Hi guys, welcome to this demonstration of Chemistry AR+. This is Neil Bergenroth, the developer of Chemistry AR+. And I wanted to thank you for watching this demonstration. I am an iOS developer in Tulsa, Oklahoma, but more importantly, I am a chemistry teacher at Holland Hall School and developed this app to help my students learn the different aspects. So what we're seeing here is a visualization of the tetrahedral configuration. So methane would look like this because it's one carbon in the middle and 4 hydrogens on the outside. So the power of augmented reality is it allows you to build environments that are interactive and allow for better visualization of things that don't necessarily pop off the page per se in a textbook. So what we've got here is a list of all the different molecular geometries. So if I wanted to look at octahedral, for example, I could do that right here. And so all of the molecular geometries are in this app. Going to the next view, I think this is the first 18 different elements. I think this is a great opportunity to get middle schoolers involved in learning about the atoms. So for example, if I pick chlorine, and there's a Bohr model representation of the chlorine atoms. If I start the animation, all of its 17 electrons are going to start spinning around, and I can walk into it and look at all those electrons and then walk right up to the nucleus and count the number of protons and neutrons in there. So the protons are actually red and the neutrons are white. And so you can imagine how interactive this might be for a middle school student or something like that. This app runs on iOS devices, anything with an A8 chip, so an iPhone 6s or later, and pretty much any iPad 2017 or later will run this. There are molecules in here as well. So for example, if I was an organic chemistry teacher, I could look at ethane, which is eclipsed. And as you notice, as it comes around, those hydrogens on either side, the white spheres are hydrogens and the black are carbons. So when I walk around this and it lines up, you'll see that they're exactly the same. We call that ethane that is eclipsed. Alternatively, we could look at ethane that's staggered, and I think you'll see the difference. The staggered ethane has hydrogens that are staggered, so they're not lined up with each other. So you learned a little bit of organic chemistry today. Not so bad, huh? And so the other thing we've gotten here, and I'm very proud of this tab, is the atomic size trend, for example. So trying to visualize, what the different sizes of the atomic radii are. As we look at this, we start high on the periodic table, and as we add more electrons to those lower atoms, the atomic radius gets bigger, and as we move over to the other side here, they get smaller, and therefore you're seeing a real good visual representation of the periodic trend for atomic size. We've also got electronegativity here. Kind of proud of this one. This is pretty cool. It kind of emerges out of the periodic table, and once again, those atoms that have low electronegativities in the bottom left-hand corner, loads of electrons, pretty large radius, so they're pretty happy to let go of their electrons, whereas those things that are smaller, like fluorine, for example, is the highest electronegativity on the table there, around about 4.0. We've got other things we could visualize here, like atomic orbitals, and we can spin those around and look at them however we like. And so just a really cool way to visualize all these different things that you might be talking about in a chemistry classroom. One of my personal favorites here is hydrogen bonding. The purple there represents the hydrogen bonding, so we can start that simulation, and the hydrogen bond forms because of the negative charge on the electrons and the positive charge on that hydrogen, because it's connected to another oxygen, which is a very polar bond, which creates these hydrogen attractions. So hydrogen bonding, pretty cool, pretty common topic, both in biology and chemistry here visualized in augmented reality. And then finally, the building part of the curriculum is looking at various different parts of the atom. So here's kind of like a middle school activity. You can export this out of the app with the button below, and it's also got a teacher key to it as well. And so there's lots of different things you can, so here are the answers for that. I'm slowly building that curriculum as we go. And so I am the developer, Neil Bergenroth, you know, in summary, I think this provides an excellent way for students to learn chemistry in a fun and interactive way. It also helps them. Move around and you know, really visualize some concepts that are pretty tough to see just necessarily on the board or on the page. It's a fun way to look at chemistry, and so I appreciate your consideration of my entry in the simulations category, and look forward to a great conference. Thanks, guys.